Hey guys, so I basically just wanted to give you another resource for connecting discontinuities, graphs, and what they look like on graphs, and then limits. So you can go ahead and fill in this table as it's filled in on here. I didn't want to try to write out all of this because, as you know, my handwriting can get a little messy. So I'm just going to talk through this bit by bit, though, so it's kind of important for you to be listening as well as writing down. So the first discontinuity we're going to talk about is an infinite discontinuity. Your graph should already be on there for you, but basically anytime you see a vertical asymptote, that's where you have an infinite discontinuity. And what that means is your limit as you of your function as you approach a certain value from either the right or the left means your graph will go to positive infinity or negative infinity. And we can kind of see that on the graphs, right? So they can either both be going down, both be going up, or you could have alternating ones as well. So basically, anytime you run into this or see this limit notation for any function, automatically you know that you would have an infinite discontinuity or a vertical asymptote at that value, okay? For the next one, for a removable discontinuity, basically what happens is you would have a hole with either a point somewhere else or just a hole. And the two options limit-wise that would happen for these types of discontinuities would be, first of all, f of a would just not exist. So that would be an example of this piece. So that would be number one, you could just not have a point, okay? The other limit possibility for this is that you do have a point and you do have a limit, but they just don't equal each other. So that would be an example of number two. Okay, those are two different ways that you would get a removable discontinuity. For a jump discontinuity, obviously your graph hops from one place to another. This only occurs in piecewise functions where your left-hand limit and your right-hand limit aren't equal to each other. So you won't have to ever identify a jump discontinuity if you are not given a piecewise function. And then last but not least, horizontal asymptotes technically aren't discontinuities, so I just said they may be continuous. So horizontal asymptotes basically happen anytime your graph approaches something, a number to the left or to the right. So like as your x values goes forever to the right, your graph approaches some value. So basically, if you go to positive infinity, your graph would approach some constant L, or negative infinity, you'd approach some constant M. And then we would say that those lines, y equals L and y equals M, are horizontal asymptotes. If it makes you feel better to put in actual numbers here instead of L and M, you may. So you could put in like 2 or negative 10. And that means that 2 and negative 10 would be horizontal asymptotes. And so if you are given the information that you have a limit of a function which actually equals a number as x approaches positive or negative infinity, that connection in your brain should be automatically be that there is a horizontal asymptote at y equals whatever that number is, okay? So this is just a nice reference chart to have and to kind of connect everything we've been talking about with discontinuities, limits, and graphs. So go ahead and make sure you have that whole thing filled out, and then feel free to continue practicing and let me know if you have any questions.